Just a, so we have direct current, we have alternating current. Direct current means it's like electrons are moving in a straight line. Alternating current means electrons are changing polarity 50 to 60 times in 1 second. Like power ratings are printed on every electrical appliance. Example, like this is 10 watt, 10 watt it means it is a power. 2 amp means that much is a current. And we have 230 to 240 volt AC. Means this much is the potential difference required to run the device. So this is that much is the potential difference in the wall outlet. In the wall outlet, that much is the voltage, 230 to 230 voltage AC is there. AC potential difference. And then 50 to 60 hertz. 50 to 60 hertz. This is the frequency. This is the frequency. Electrons are changing the polarity 50 to 60 times in 1 second. Or sometimes it is written CPS. CPS is cycles per second. That is also a unit of a frequency. Hertz also a unit of a frequency, and CPS is also a unit of frequency. But the power, the problem is here we are not going to discuss about this alternating current again. Just we have Rama means they have Lord Rama and we have some normal Rama also, right? Is it not? So now
Yes,
don't go in that way alternating current. If I say that alternating current which is fatter, we cannot increase or decrease the frequency of that. Is that clear? Now there is a frequency generator. Okay, there is a frequency generator. This is very, very important. Frequency generator, which is generating a frequency alternating current, which is producing alternating current. Okay, AC, it produces AC. Means if you touch it, you won't get any shock. You understood? But you can increase the frequency and decrease the frequency. Is that clear? There is a device called frequency generator. Okay, frequency generator, oscillator. One more name is that is oscillator. Okay, then again you will ask, sir, what is the difference between oscillator and an amplifier? Okay, amplifier means I'll write that also, because these are the small things which you should know, which will make the lesson simple, easy to you.
Amplifier increases only, right?
It increases the amplitude of the signal. It increases the amplitude of a signal. It increases the amplitude of the signal. If people who are not there, your online class 2 to 4, you are not there.
Sir, I had added.
Aha. What about you?
Sleeping.
I was not well. That's why I was sleeping.
Not well.
I asked
Actually,
him. I asked him.
Sir,
Sir, Ashaz joined.
Sure.
Sir, Ashaz joined.
you're asking
You were
me.
there.
Yeah, give us. That is the reason.
Good
Okay,
boy.
amplifier. Amplifier means
thank you, sir.
it increases the amplitude of the signal. Whether it is a sound amplitude, like amplifier means mic, simple example, a speaker. So it amplifies the signal. Suppose your sound is there, it will increase the sound signal. If you are giving the voltage, it will increase the voltage. It's such type of thing. Now, device, that is amplifier. Next is oscillator. Okay, oscillator. What is an oscillator? It converts, some people say it converts AC to DC. Sorry, it converts DC to AC. Some people say it converts DC to AC. Or it converts.
Don't search in Google.
Okay, it
Search
converts.
itself.
There are different definitions. It converts DC to AC, that is alternating current, not like alternating current, into AC signals, I will say. How it is actually?
Yeah.
It is like this. See, it's a sine wave. It's a sine X graph.
Sir, this is there in physics lab.
No, it is not there.
So
This is
this
cos
thing,
X.
no?
This is cos X graph.
This is there in physics lab, no?
No, that is not a, that is a generator. We have only voltage things. All voltage
So,
equipments are.
I've seen this.
I have seen this.
All voltage equipments are. That also has the same panel.
Oh,
Looks like the same, but is a we have 2 pins output, and from there when you connect it, we have like on that it will be printed like this. See, you can see there also. Like it will be a sine X. You want sine X graph, you want cos X signals, or you want square waves. Is it there?
yeah.
You want
Oh, yeah.
square waves, or you
Ah,
want
yeah.
sawtooth wave.
That is sin X graph.
This is sawtooth wave, or you want a triangular wave.
Sin
Sir,
X
but
graph.
why do we need these graphs?
Yeah, no curves. These are the outputs.
Because the last question.
Means hey. Now,
You are better online. only.
no, it's so what is happening, it converts AC to DC signals. Means like you want a, like we studied about waves in grade 11, right? We studied about
Yes,
waves
sir.
in grade 11. In that waves, we studied about, amplitude, frequency, time period. You remember amplitude, frequency, time period, phase, and all. Yeah. So
Yes, sir.
suppose if I say I need 1 kilohertz frequency sine signal. So there is a knob over there. You have to set the knob. Like buttons will be there. 1, 2, 3, 4. One for sine, one for cos. One, not all will work at the same time. Only one at one time. And you will hear signal like this. This type of output signal will be given. So if you connect it to the CRO means cathode ray oscilloscope. If you connect this, like suppose this is the box. Like suppose this is the box. Now there is a knob here. This is the display. Okay. There is a knob here. This will give the voltage. There is a knob here. This will give a time period. Okay. The time period means frequency. You can easily calculate here. Time period and frequency. T is equal to 1. See, the frequency and time period is associated with this formula. T is equal to 1 by F. Okay. Or if in some of them it is given F here. In some of them it is given T. No need to worry about it because it is already giving any whatever you want.
Sir,
You
what
can.
is it?
Is it like it's a panel, like it's a box, like this, a device. Here, there will be, suppose if you want a sine signal, there is one button here, or one, what is that called? Switch. Okay.
Switch is
If
there.
you want to switch,
Switch.
you can switch on any one at one time. Like one is sine switch, cos switch, square wave, triangular wave, sawtooth wave, such
So
type
how
of.
will we know which way we
Whichever you want, you take it. Whichever you want. Suppose you want to go with sine is very simple to understand. You take the sine wave, finish. How much you want? Now suppose, example, is this completed?
Yes.
Now, how much you want? Where is that master? शुरू का थोड़ा difficult है. If you can understand that, then the whole topic is easy. Okay. So suppose I am removing this. Can I remove this part? This is a power.
Yes, sir. Yes, sir.
On any device, suppose I will just show you the fan here. There is a fan here. We'll just show you the fan. See here. You can see this one. What is this? AC 221. Did you read this one? 221. This is how much? 50 to 60 hertz. ये कितने वाट का है? 60 watt. Are you able to see this one? On every electrical appliance, you have this type of thing. Okay. So on any electrical appliance, okay, you have this type of thing printed on that. Okay, you have this type of thing printed on that. Okay.
So,
Yeah. Yes, sir.
so what is the difference between the sin x and cos x, the second graph?
Sin x means it starts from 0. Both
Yes, sir.
start from 0, but this will start from 1. You know what?
So the one on the other side.
Huh? One second.
So the spike.
Sir is not here. Chill out.
Chukkar, yeah. Chukkar.
That's
You
true.
don't-
It says chukkar.
Weird stuff now.
Sir, that is true only, no?
Okay, but still, the way you said it.
Sir, अच्छा लाग लगा.
Now see here.
Sir, I said you're not
So
there.
sine graph.
So not this graph, the other one.
This one.
No, the other one on the
This one.
left. No, sir.
This one.
Yes, sir. What's the difference?
This
between
is
those
a
two, sir?
sawtooth wave. Sawtooth. Okay.
Okay, sir.
Like a saw. You know sawtooth. Have you seen?
Yes, sir.
Like a blade, man. It's a triangle.
Yes, sir.
There are different types. This is not there in the book. That's a problem. See what type of wave you want. You have to first decide. Okay. So let us confine ourselves only to sine wave for time being. Okay. Is that clear?
Yes.
Instead of all these waves, we will confine ourselves to only sine wave, because in the book also he confined to sine and cos only. Is that clear? Now how much frequency you want? Suppose if you want a frequency here, like of maybe 10 hertz, very low frequency. Then what will happen? You just draw the signal. You want 100 hertz. How will you draw? See? Did you understand? This is 100 hertz
Yes, sir.
and this is 10 hertz. You increase the frequency. You want to increase the amplitude, you can increase that also. See? I'm erasing this. Huh? So now,
Yes, sir.
suppose if I want to increase the amplitude with the same 10 hertz, I can increase. See? I can increase the amplitude. I can increase the time period and decrease the time period because it depends on the frequency. More the frequency, less will be the time period. More is the frequency, less is the time period. Understood? So it follows the frequency method F is equal to 1 by T. Is
Sir,
that
why
clear?
did you talk about the sin x and cos x graph here?
Yeah, because one should know there are different types of graph, because in the book sometimes he's using cos also, cos omega t.
Oh,
Sin omega t he's using, cos omega t he's using. So one should know what is sin omega t and cos omega t for that reason. And there are, you might again ask, sir, only these are the two in the nature? No, there are so many waves. So no need to worry about sawtooth wave, square wave, and triangular wave. Only we are concerned with sine wave and cos wave. But in our textbook, he is asking sine cos only. He's not asking anything else. Is that clear?
Yeah.
Okay. Okay. Now,
Sir, what's written below the 100 hertz graph?
what is that?
What is written below the 100 hertz graph?
100 hertz. F is
So
equal to
the
1 by
100
T.
hertz.
F is equal to 1 by. This is a frequency. There is a relation between frequency and time period. When you increase the frequency, time period will decrease.
Yes, sir. F is equal to 1 by T.
1 by T. F is equal to 1 by
Okay,
T.
sir.
That is the formula. Is it clear, all of you? Is this clear?
Yes, sir.
Okay. Now, so did you understand? We are not discussing about the alternating current which is coming out from the wall outlet. That is fatal. Means that is very dangerous. Okay. We are discussing about the oscillator thing. Oscillator, or we are discussing about the alternating current which is coming out from the oscillator. So oscillator gives AC current. Is that clear now? The problem with the teachers is not, there are few, they just start alternating current. Okay, there is F is equal, A is equal to that. So and voltage, this is the voltage equation, this is current equation, and just go ahead. It's not like that. So one should know the difference. Alternating current means, don't think like, oh, okay, shall I try with this? No, never do that. Can you increase the frequencies and finish, gone.
for you, sir.
Okay, is that clear?
Yeah, sir.
Don't try that. Okay. No, I will try, sir, like that.
Sir, Aaron will do this.
Yeah.
Sir, he like to torture himself.
Okay. Is this clear, all of you? Clear? So if you,
Yes, sir.
but the problem is, see, you can increase, see, not like our alternating current which is having listen, not like alternating current which is having 100, like 50 to 60 hertz in 1 second. That is very dangerous. But this is what, if you touch it also, you will not get any shock with this, because it's converting DC to AC, but DC to AC signals, not alternating current. If that is that clear? AC signals means like having a like this. But why we study again this one? So what is the significance of this, and why do we study this? If you go to communication chapter, which is deleted from the portions now. Earlier communication was there, electronic communication was there in the syllabus. After semiconductors, there was electronic communication lesson was there. In that, like suppose I want to talk to my friend who is in Abu Dhabi, okay, or some other place. So what I have to do earlier, now we have wireless communication. Now we have wireless communication, but before that we used to have physical communication. So what we used to do is, now what we were doing is, like this is a sound signal. Okay, this is my information signal, what I am talking. Now this is made to add with what? High frequency charge carrier. See, so my sound signal, whether it is electrical signal, it cannot go for a far distance. So what do? Is they add this my information signal to this signal. Then what happens? My signal will get modulated. That is why, in the radio we have FM, AM. Do you see that? FM is frequency modulation. AM is amplitude modulation. This takes place. Once it is modulated, you can release that wave and it can go to any distance. Maybe 30 kilometers, 40 kilometers, like that. It can travel. Those signals can travel to a far distance. And it is received by the antenna. Again, in antenna, once it comes to the antenna, there's a demodulator. There's a modulator, demodulator. Modulator will add the signal to this one and make a modulated wave. Understood? So this was a modulated wave earlier. When we studied this one, see, modulation, demodulation. See, it was like this. This type of wave. This is the modulation, amplitude modulation. Okay? Amplitude modulation. This is high frequency charge carrier. So why do we study all these things? Because we want to use this in communications. Is that clear? We want to use all these things in the communication chapter. For that reason, we are studying about this. Once we know how to use this, then you can apply anywhere. Understood now? Even your computer, speaking to any computer or a laptop or a mobile phone or anything, everyone is having a frequency generator. You know that? Everyone is having a frequency generator on an oscillator. How the frequency of how the speed of the computer works, or how the speed of the phone works, it depends upon the frequency of the oscillator. Example, if the frequency you might have seen in the processors, If the frequency of the oscillator is how much? Let it be 2.4 gigahertz. Yeah, this is the frequency of Pentium 5 processor or i5 processor.
NCERT is also there.
Yeah, it is there. No, I'm just taking one example. If the frequency of the oscillator is 2.4 hertz, what will be the time period? Can you solve that?
1 by 2.
1 by 2.4 gigahertz. Okay. So what is giga, man? Our Ashas will say. What is giga? 10 to the power of
10 to the power
10 to the
of
power
Very
of
small.
huh?
1 second, 1 second.
10 to the power of
7 second.
ah,
Yeah.
1 second over. Ah,
10 to the power of 9.
very good. 10 to the power of 9. So that is 1 by 2.4 into 10 to the power of 9
Thank you so much.
hertz. Okay, so that will become time period. So now what we are doing here is, see, now here, see the time period is how much now? Suppose 1.1 by 2.4, how much it is?
1 by 2.4.
How much it
It's
is?
a good question.
Good English max questions.
Into 10 to the power of minus
Sir,
9.
0.416.
0.416. Okay.
Brain calculation.
So so we can say 0.4 nanoseconds. Means if your frequency of the oscillator which is fitted on the motherboard, there is a frequency oscillator which is fitted on the motherboard in everywhere. In phones also it is there, in the laptop it is there, in your tablet also it is there. If the frequency of the oscillator, if the that's a i5 processor. i5 processor has that much.
Refreshes is pulse. Only
Okay,
once.
that giga means 10 power. So that much is the frequency. If that is the frequency of the oscillator fitted on the motherboard, then the time period is this much. What is the meaning of this? Means to solve one instruction of your program,
That much time the command.
that
is
much
that.
time will be taken. Suppose you have 10 lines instruction 1, 2, 3, 4, 5. एक लाइन को सॉल्व करने के लिए how much time it is taking? 0.4 into 10 to the power of minus 9 seconds. माने not even a second. It is 10 power minus 9 seconds. माने एक सेकंड में it can solve 10 power 9 instructions. What is 10 power 9? कितने हजार? माने 10 millions or 10 billions?
10 billion.
10 billion instructions in 1 second. 1 second. That much is the time period. That much will be the free.
Sir, why minus 9?
So how much will be for
Yes.
4 point?
Yeah, sure.
That's all. So you understood now. So to solve one instruction of the program, it is taking this much time. Means in 1 second, 10 power 9 instructions can be solved. 10 power 9 means how many? 1 billion instructions can be solved in 1 second. Got it now? Did you understand now? Now we have quad processors, quad core. Now you can understand now.
4.3 gigahertz, how much will it be?
You calculate 4.3. Just 1 by t, you do it, finish, you will get the
That
answer.
much lazy you are.
Now you have terahertz, not only giga. Now in the market, you have terahertz. Okay,
iPhone 13.
terabytes, terahertz, iPhone and all.
iPhone
They have
13.
high frequency supercomputers are there, MacBook also. They solve many instructions. That is why earlier to download one movie or to watch a movie, it used to take long time downloading. Now within few seconds it can download. Not only that one. Now to download a movie 4G, how much time it takes? Maybe 20 seconds, 20 minutes or 25 minutes to download one movie. When 5G will come into power, now already started. So it will take only 2 or 3 minutes to download 1 2 hours movie. 5G. With 5G, we can download because the communication
Sir, now
like
phones
there
are
are
5G
bits.
only, right?
We are जाएंगे. The old will not support.
So iPhone and all is 5G only.
Even this is
4G and 5G. अभी जो नया आ रहा 5G है सारा. There is 5G only. The old mobile phones, like for example, this mobile phone is Samsung mobile phone. Okay, it's a very old one. It will not support even 4G also. Means the system is being advanced now. Understood now? Is that clear? So did you understand? So these signals, first of all, modulation. Okay, then that is frequency of the oscillator. So are you using any alternating current inside the board, on the board? No. What we are doing with the adapter, there is an adapter now. So I'll just take this adapter. So there is an adapter here. So this is the adapter. What is the function of adapter here? The function of adapter is to convert AC current to direct current. AC current to alternate. This is alternating current. It will go to the alternating current. It will convert AC to DC. Okay, and this pin is giving a DC current, maybe whatever it is, 12 volts or 24 volts, whatever it is. It is connected to the motherboard. From there, it is dividing the voltage and giving to all the components. Is that clear? Understood, all of you? So that is how it works. But
Yes, sir.
but there is a cycle. You know how if you want to run your laptop to a high frequency faster, then don't go with the Celeron processor. Like in the offer, they say Celeron processor. Looks like the same. People who don't know, like those who are not good familiar with the science and all, they are not that much familiar, right? They think, okay, I'm getting everything for only